Good morning to all of you. So, dear students, today we will study the next chapter of our engineering graphics and modeling through AutoCAD. The topic for today's lecture is projection of lines and projection of planes. So, in the previous class, we have discussed about the various reference planes and the concept of orthographic projection. Today, our topic is projection of a straight line. So we will consider the different cases of the line. Case 1 is a vertical line, that is a line perpendicular to HP and parallel to VP. Then we will discuss line parallel to both the reference plane, that is line parallel to HP as well as VP. Then line inclined to one plane and parallel to other. In this, we will discuss line inclined to HP and parallel to VP. Then we will discuss line inclined to VP and parallel to HP. And finally, we will take examples and discuss about the line which is inclined to both the reference plane, that is line inclined to both HP and VP. So, a line perpendicular to HP and parallel to VP. Say this is vertical plane, this is horizontal plane, and a line is given, and this is a line which is perpendicular to HP, as HP and VP both are perpendicular to each other. So when we draw a line perpendicular to HP, it will automatically become parallel to VP. Now in the front view, we will see the projection of line as true length which is perpendicular to XY line. And in the top view, we will get a point in place of line. So, when the line is perpendicular to HP and parallel to VP, in front view we will get true length perpendicular to XY, and in top view we will get a point. The same point will represent the point A as well as point B. Okay. Now, the case 2, line is perpendicular to HP, line is parallel to both horizontal plane and vertical plane. This is a line AB which is parallel to both HP and VP. When we see this line from front view, its projection will be given on vertical plane, and this projection, the front view of a line will be represented by A dash B dash which is parallel to XY line. And in top view, the projections are point A and point B. Again in top view, the line AB, that is the top view of the line AB, is parallel to XY line. So, when the line is parallel to both HP and VP, in front view as well as in top view, we will get a line which is the true length and which is parallel to both HP and VP. When we draw it in reference of XY line, as I have told you in the first case, when the line is perpendicular to HP, in front view we will get true length and in top view we will get a point. And when the line is parallel to both HP and VP, the final projections are parallel to both XY line, both in front view as well as in top view. Okay. Now, case 3, a line inclined to HP and parallel to VP. This is the pictorial representation of a line which is inclined to HP and parallel to VP. So, the angle of inclination with HP is represented by angle theta, and this theta angle will be seen in the front view. This is the pictorial representation from front view. When we project the projection of a line, the front view of line will represent true length, It is represented by A dash B dash, which is inclined at an angle of theta degree. And in top view, when we project the top view of the line will be parallel to xy, but its length is reduced as the line is inclined to HP. So in top view, we will get a line parallel to xy, but the length of line will be reduced. So these are the final projection of the line, which is parallel to VP and inclined to HP at theta degree. Next case, line inclined to vertical plane and parallel to horizontal plane. Again, this is vertical plane, this is horizontal plane, and this is the line AB, which is inclined to VP and parallel to HP. When we see from top, the angle of inclination with VP, that is phi, will be represented in the top view. The top view of the line will be of true length, which is inclined at phi degree, and in front view, we will get a line of reduced length, which is parallel to xy. So, when the line is parallel to HP and inclined to VP, top view will give true length, which is inclined at phi degree, and front view is parallel to xy but of reduced length. So, these are the final projection of a line which is inclined to VP and parallel to HP. Now, next case, a line inclined to both horizontal plane and vertical plane. Here, this is a pictorial representation of a line AB which is inclined to both HP and VP. The angle of inclination with HP is theta and the angle of inclination with VP is phi. When we project the line, the front view of the line, it will be seen on vertical plane. Here, the line is of reduced length and which is inclined at an angle of alpha. This alpha is the apparent angle of line with horizontal plane. Again, we will project the top view of the line. The top view of the line is again the line of reduced length which is inclined at an angle of beta to the vertical plane. Here, beta is the apparent angle with VP. When the line is inclined to both horizontal plane as well as vertical plane, the final projections are of reduced length in both front view and top view, and the final angles that are apparent angle alpha beta are so that the alpha is greater than theta and the angle beta, that is apparent angle with top view, is greater than phi, and this is the final projection of line. Now we will see some problems, okay, here. So when the line is inclined to both HP and VP, the final front view and top view both are of reduced length. Now, to find the true length, we have to rotate the view and make it parallel to one of the reference plane. Okay, so when we rotate the top view of the line and project it on the locus of front view, and by joining A dash to B dash, we will get the true length of the line in front view. And the angle of true length in front view is called theta, that is angle of inclination with HP. Similarly, if we have to find angle phi, that is the angle of line with VP, we will rotate the front view of the line and make it parallel to XY. And when we rotate, project it on the top view, we will get the angle theta as shown in figure. So, theta and phi are the angle of inclination of true length, while alpha and beta are the angle of inclination of final projection, that is final front view and final top view. And this is how we can solve the problem. After solving the problem, we can see that the final projection B dash and B lie on a same projector which is parallel to both HP and VP. So, if we discuss all the parameters of line, if we discuss all the parameters of the line, a line has a starting point A and the end point B. The shortest distance between the point A and B is called true length. The angle of true length with HP is represented by theta. The angle of true length with VP is represented by phi. Final angle of final front view of a line with XY is called alpha, that is the apparent angle of front view. Similarly, angle of top view with XY is called beta, that is the apparent angle with VP. When the line is inclined to HP, the top view of line will be of reduced length. Similarly, when the line is inclined to VP, the front view of a line is a reduced length. When the line is inclined, its position of point B changes, so that is called locus of point B in front view as well as locus of point B in top view. And the distance between the projectors of end point of a line, that is projector of A dash and A and B dash of B, is called the distance between projectors. Now, it should be noted that all these parameters are related to each other, and by giving any four of these parameters, the problem of line can be solved. So we must understand the correlation between all these parameters. Now we will take some examples and we will solve a line which is inclined to both HP and BP based on all these parameters. So a problem, we have taken a problem. The problem is as line AB is 75 mm long and it is inclined at 30° and 40° to the HP and VP. Point A is 12 mm above HP and 10 mm in front of VP. Draw projections. So, in this we have given the true length of the line, that is 75 mm, and the angle of inclination with HP and VP, that is theta and phi. Theta is given as 30° and phi is given as 40°. And the position of point A is given as 12 mm above HP and 10 mm in front of VP. So we will start the problem by drawing a line XY, and first of all we will draw the projection of a point A which is 12 mm above HP and 10 mm in front of VP. Okay, like this. Now we will consider the line parallel to both the reference plane, and we will draw a line from front view and top view equal to the true length. Now, the angle of inclination with HP is given as 30 degrees. So we from point A dash, we will draw a line at an angle of 30 degrees. By taking true length, we will cut an arc so that we will get a point B dash. Similarly, in top view, we will draw a line from point A at an angle of 40 degrees of true length. Now, from point B1, we will draw locus from point B1 dash, we will draw a line locus of front view. Similarly, from point B1, we will draw a line that is the locus of top view. From B1, we will drop a projector up to front view. This is the point where we will get the reduced length of front view, and we will rotate this reduced length of front view to the locus of front view, that is B dash. We will get the final point B dash, and by joining A dash B dash, we will get the final front view. The angle of final front view is alpha. Similarly, from B dash point, we will draw a projector to cut the locus of B1 at some point, and this is the final point B. By joining this point B to A, we will get the final top view of the line. And the angle of top view is beta. Okay? Again, we will take one more problem as shown in figure. The given problem is line AB 75 mm long makes an angle of 45 degree with the VP, while its front view makes an angle of 55 degree. Point A is 10 mm above HP and 15 mm in front of VP. If line is in first quadrant, draw its projection and find its inclination with HP. Again, in this problem, the given line is AB, its true length is 75 mm. It makes an angle of 45 degree with the VP, this is phi, and its front view makes an angle of 55 degree, so angle of front view is alpha. The position of point A is given, so we will start by drawing a line XY and marking point A, which is 10 mm above HP and 15 mm in front of VP. Now we will consider the line to be parallel to both the reference plane. Okay, like this. Okay. Now, the top view of the line, it has been given that the top view of line makes an angle of 55 degree. So from point A, we will draw with the phi angle is given as 45 degree. So from point A, we will draw a line at an angle of 45 degree and equal to true length. From point B1, we will draw a projector to cut the front view at a point, and we will draw the locus of the line. Similarly, from point A dash, we will draw a line at an angle of 55 degree. Now, we will draw the locus of front view also. Now, from point B dash, we will draw a projector to cut the locus of top view at a point B, and this is the final point B in top view. By joining point A to the point B, we will get the final top view, and the angle of inclination of final top view is beta. Again, to find the angle theta, we will rotate the line AB parallel, and from that point we will project a line on the locus of B1 dash. This will give you the true length of the line and the angle theta. Okay. So, in the similar manner, we can solve any type of question of line which is inclined to both HP and VP. One more problem is given here. So, by using the same methodology, we can solve this problem also. Okay. Front view of the line is 50 degree inclined to XY and measures 55 mm long, and top view is 60 degree inclined to XY line, and the position of a point P is given. So here we have to find the true length of the line. So what we will do, we will rotate the line in the reverse order to find the true length of the line as demonstrated in the diagram. These are the final projection alpha and beta. By rotating front view, we can get the true length of the line in top view like this. Similarly, by rotating the top view, we can get true length of the line in front view. And the angle of inclination of true length in front view is theta, and the angle of inclination of top view, true length in top view is phi. Okay. Now, we will take another topic, that is projection of planes. The basic difference between line and plane is that a line is a one-dimensional figure, whereas a plane is a 2D shape. or we can say that a plane has surface area, or we can say that a number of lines when joined together to in a closed manner it will form a plane. To explain plane, when we talk about the line, when we say that the line is inclined to HP and VP, in that case, we consider the length of the line. While in case of planes, when we say that plane draw the projection of plane, it means here there are two dimensions. One is the side of plane and other is the surface area of the plane. So, when we say that a plane is perpendicular to any reference plane, it means the surface area of a plane is perpendicular to that reference plane. We have considered one example of a rectangular plane. In first case, the plane is perpendicular to VP. In second case, the plane is perpendicular to VP and parallel to HP. While in third case, the plane is inclined to both HP and VP. So we will take up from first example. Here, this is a plane, rectangular plane, which is perpendicular to VP and parallel to HP. So when we see this plane from front view, we will get its projection as a line in vertical plane, means in front view, because the plane is perpendicular to VP, so the front view of a plane will be a line. While when we see it from top view, as the plane is parallel to HP, so the top view of a line will give you a rectangle of the same size or same true shape. So when the plane is perpendicular to HP, its top view will be of true shape. While in case 2, when the plane is perpendicular to VP and inclined to HP, in front view we will get a line which is inclined to XY because the plane is inclined to HP. And the angle of inclination of this plane is called theta. While when we see it from top view, instead of getting true shape, we will get a reduced shape because the plane is inclined to HP. So while we see from top, the plane will be of lesser area as compared to its true area. Here, in case 3, we are considering a plane which is inclined to both HP and VP. When the plane is inclined to both HP and VP, we will get a reduced shape in front view as well as the reduced shape in top view because the plane is inclined to both HP and VP. So these are three cases of plane. When we draw it in orthographic projection, in front view we will get a line and in top view we will get a true shape. In case 2, in front view we will get a line, but this line will be inclined at theta degree, that is the angle of inclination with HP. And in top view we will get an area lesser than the previous area. In case 3, when the plane is inclined to both HP and VP, in front view as well as in top view we will get reduced shape. And this is the typical case of plane which is inclined to both HP and VP. So we will understand the case 3 by using a problem. I have taken one problem of the similar rectangle. The problem is as rectangle having side 30 mm and 50 mm is resting on HP on one of its smaller side, which is inclined at 30 degree to the VP, while the surface of the plane makes an angle of 45 degree with the HP. Draw its projection. So, as in the given problem, the surface is inclined to HP. So, in the initial step, we will consider that the rectangle is parallel to HP. So, when we consider the rectangle as parallel to HP, we will start from the top view and we will draw the true shape of a rectangle in top view by keeping the smaller side perpendicular to xy line. Now, in the front view, this is the top view and we have named the rectangle as A, B, C and D. So the front view of a rectangle will be a line which is parallel to xy. Okay. So in the second step we will get a line instead of plane, that is A dash B dash and C dash D dash. Now the surface of the plane is inclined at 45 degree to the HP. So in step 3, we will incline the front view of a line at the given angle, that is 45 degree. And the third step is always a copy of step 2 at a given angle. In the front view, this angle is theta. Okay. So this is the surface inclined to HP at theta degree, A dash B dash C dash D dash. So third step is always a copy of second at theta degree. Now for projecting the top view, we will draw projectors from point A dash B dash and projectors from point C dash D dash. Again, in top view, we will draw projectors from point A, B, C, D to cut the vertical projectors, and by the intersection of this point, we will get point A1, B1, C1, D1. By joining this, we will get the reduced top view of a plane because this plane is now inclined to HP. Now, in step 5, we have as given in the problem that the shorter side is inclined at 30 degree. So the step 5 is the copy of step 4 at a given angle. Here the given angle is 30 degree. So from xy line we will draw a line at an angle of 30 degree and we will keep the shorter side on that angle and we will copy the shape of step 4, that is reduced shape, in step 5. For drawing the final front view, we will draw the projectors from all the points A1, B1, C1 and D1 and horizontal projectors from front view, that is A dash, B dash, C dash and D dash. And we will locate the point of intersection of all the 4 points like this as shown in figure, and by joining all these points in a given sequence A1 dash, B1 dash, C1 dash and D1 dash, we will get the final projection of a plane which is inclined to both the reference plane. By using same procedure, we can solve any problem of planes. Here we have taken one more example. A 30-degree 60-degree set square of longest side 100 mm is in VP. The longest side is in VP and inclined at 30 degree to the HP, while the surface is inclined at 45 degree to the VP. Draw its projection. So we will start this problem again by seeing that the surface of the plane is inclined to the VP. So in the initial step, we will consider the plane to be parallel to the VP. So this problem will start from front view. As the longest side is to be kept in front view, so we will keep the longest side perpendicular to XY. And by drawing lines at an angle of 30 degree and 60 degree, we will complete our first step, that is front view of a set square. In second step, we will get a line in top view by projecting these points on XY line. Now, as said in problem that the surface is inclined at 45 degree, so in step 3, we will copy this line at a given angle, that is 45 degree. For fourth step, we will draw projectors from top view and front view to locate point A, B and C. By joining these points, we will get the reduced front view of a set square. Again, as given in the problem, that the longest side is inclined at 30 degree to the HP. So in step 5, we will draw a line at an angle of 30 degree and we will copy the step 4 in step 5 at the given angle of 30 degree. The final projection, what we have to do, we will draw the vertical projectors from front view and horizontal projectors from top view, and we will locate the point, and by joining them in a given sequence, we will complete the top view of a given figure. So, in by seeing these two problems, you can understand that if the problem is started from front view, it will finish at top view. Means if the true shape of the problem is drawn in top view, then the final view will be received in front view. While if the problem starts from front view, then the final view is the top view as shown in this figure. So, by using the following methodology, you can solve any problem of planes. Here, again a problem of pentagon is given. By following the same procedure as we have followed in the case of rectangle and set square, we can also solve this problem. Okay, thank you. Thank you very much.